Lesson 9, Geometric Meanies. Jumpstart. Do you know what a prime number is? A prime number is a number that can only be divided evenly by itself and 1. Some of our prime numbers are 2, 3, 5, 7. Not just odd numbers though, 9 is not a prime number. 11, 13, 17, 19. Do you remember prime factorization from junior high? Prime factorization is when you take a number like 1,875 and you break it down into its prime numbers. Well, just think of any way you could multiply two numbers and get 1,875. It does end in a 5, so it will divide by 5. 1,875 divided by 5 is 375. So these two numbers are in there. But 5 is a prime. Now let's break down 375. That will divide by 5. You get 5 times 75. Break down 75, you get 3 times 25. And 25 is 5 times 5. So put all together and in order, 1,875 is 3 times 5 to the 4th power. 1, 2, 3, 4. If you did that to all of these numbers, each one of them would be unique in its own way. Here they are. And 1,280 could also be written as 5 times 4. For every one of those 8 2's, they could be combined into a 4. And so this would be 4 to the 4th. Each one of them is unique, but really, the goal here was just to be able to write the prime factors of a number. The Explore for today. So you have a table. It is a geometric sequence. Find the missing term. Well, we're going to write an equation of this situation. It takes 2 jumps to go from 1 to 3. So if we start with the number 3 and we multiply it by a number, call it R for ratio, 2 times, then the result is 12. Is there a shorter way to write R times R? Sure, that would be R to the 2nd power. Now, one of the things that we did when we were solving equations in junior high, sometimes we divided by a number, and it made things simpler. So we're going to do that here. We're going to divide by that first number. So R times R is 4. What number times itself gives you 4? It's 2. So this is 6. How do you know that? Well, the prime factorization of 4 is that 4 is 2 times 2, or 2 to the 2nd power. So obviously, R must be 2. Let's try another one. Oh, by the way, is that the only number that would work? No, it's actually not. -2 would also work, because that would give you -6 in the middle, and you would still end up at 12. So the equation would be, I'm going to start at 7, and I'm going to take 1, 2, 3 jumps I'm going to take a number times itself 3 times, or to the third power, and the answer is going to be 875. Well, let's simplify it by dividing by 7. R to the third power is 875 divided by 7, or 125. What is 125 in its prime factors? 125 is 5 times 25, and 25 is 5 times 5. So you see there are 3 5s that make 125. Well, this is saying there's a number times itself 3 times that gives you 125, or in other words, 5 to the third. Isn't it obvious? R is 5. And could that be negative 5? Well, let's fill in the numbers first. So this 7 times 5 would be 35. And then 35 times 5 is 175. So if we stuck in a negative, then this would go negative, then this would go positive, this would go negative. So no, it won't work for r equals negative 5. What about this one? Starting at 6, you would multiply times r how many times? Let's count them. 1, 2, 3, 4. Okay, so did you notice that 4 is simply 5 minus 1? That's similar to a previous lesson, isn't it? And the result is 96. Oops, I forgot my exponent. My exponent is 4, because 5 minus 1 is 4. Okay, and then we'll divide by 6. R to the 4th equals 96 divided by 6, or 16. What are the prime factors of 16? 16 can be written as 4 times 4, and that's 2 times 2, and another 2 times 2. So 16 is 2 to the 4th. R then must be 2. And if R is 2, then this is 12, and this is 24, and this is 48, and then 98. But is that the only answer? Well, if it was negative 2, then this number would be negative 12. This would be positive 24. This would be negative 48, and this would be positive 96. So it works. We could have negative 2. Okay, our last one is going to go to the 5th power. 1, 2, 3, 4, 5. So starting at 4, multiplying by r 5 times, and then that's going to equal 972. So again, we'll divide by 4, make our simplification. R to the 5th equals 972 divided by 4. It's 243. Now, you might get into a situation where you have no idea how to break down the number 243. Is there a way to find out on the calculator what number it is that I take to the 5th power, what number this is, so that when I take it to the 5th power, I get 243? And the answer is yes, there is a way to do it on the calculator. Here's the answer, it's 3. And I'll show you how I got this. I'm using the new calculator on iOS 18. So I type in my number, 243, and then I press this y root x button. And that lets me set how many times I need the factor to repeat. And the number is 5. So this expression says, what number can you multiply together 5 times with itself to get 243? And the answer is 3. In other words, 3 is not the square root, not the third root, but the 5th root of 243. R is 3. Now, can that be negative 3? Well, let's do the numbers first. This would be 12. 12 times 3, 36. 36 times 3, 108. 108 times 3, 324. And then 976. But if this was negative 3, then this would have been negative 12, positive 36, negative 108, positive 324, and negative 972. So when do you have one answer, and when do you have two? Well, if you notice the pattern, when we're taking r to an even power, we get 2 answers. But when we take r to an odd power, like 3 or like 5, we only get 1 answer. Okay, so describe your method for finding the missing terms. Okay, so write an equation of the jumps from the beginning to the end. Six, how can you tell if there will be more than one solution for the missing terms? So even power gave us 2 solutions. Odd power gave us 1 solution. These are the same beginning and ending points, but they're different kinds of sequences. So let's do the arithmetic first. This is what we did in an earlier lesson. We have number 1, 2, 3, 4, and 5. So what we would have done is we would have taken the subtraction of the numbers, 324 minus 4, and the subtraction of the place values, 5 minus 1. And that would have given us 320 divided by 4 is 80. So this is going up by 80. This will be 84. And then 164. And then finally 164 plus 80 is 244. But for geometric, you take the last number divided by the first number. And that is what the ratio to the power of 5 minus 1 is. So there is still a subtraction in there, like we did before, but now there's a division as well. 324 divided by 4 is 81. So r to the 4th equals 81. What number times itself 4 times gives you 81? The answer to that is 2. But also, no, sorry, not 2, 3, but also -3. So with the positive, this would have been 12, and then 36, and then 72. So, takeaways. Given two terms in a geometric sequence, so take the last number divided by the first number, and then for this fraction, find the root. Now, we're just going to put a little placeholder here for the root number. Okay, which root is it is dependent on the exponent. If the exponent is, say, 5, then we're going to take the 5th root. Or what we could say is that if you do the first number times the ratio to the power of n minus 1, then that's equal to the last number. From solving that equation, that's how we get our answer. So we can replace that exponent over here with an n minus 1. See you next time.